You may ask, why do we care about critical points? Well, critical points are related to those relative extrema. If we let a function f be defined on an open interval containing c, if f has a relative extremum at c comma f of c, then c is a critical value of f. In short, what this means is that my relative extremum happen at the critical values. That's pretty amazing. If I know my critical values, then I can test for the relative extremum. So my relative extremum happen at critical points or critical values. Notice what I said. I did not say all critical points are relative extremum. There are critical points that are not maximums or minimums. But what we're saying is that if there are maximums or minimums, then they happen at critical points. I hope that makes sense. All the maximums and minimums are critical points. However, there are critical points which are not maximums and minimums. So how are we going to find the relative extrema? Well, if I want to find the maximum and minimum value for a function on a closed interval, as long as that function is a continuous function on the closed interval, then the maximum and minimum values will either happen at critical points or endpoints. So if I find all the critical points and then look at the endpoints and compare and contrast those, the points with the highest value are going to be maximum, is going to be our maximum. The point with the lowest value is going to be our minimum. Let's do an example where we find the maximum and minimum values of the following function on the interval from 0 to 8. This is a closed interval from 0 to 8, which means that we are including the endpoints. Let's go ahead and do this. We first want to find the critical point, and we first find the critical point by finding the critical value. So P prime of x is equal to negative 2x plus 10. If I set that equal to 0 and solve, we find out that we have a critical value when x is equal to 5. So if x is equal to 5, we end up with a critical value. If I plug in 5 into my function, p of 5 gives me negative 5 squared plus 10 times 5 minus 1, which is 24. So I have a critical point at the point 5, 24. Now, what other points do I need to check? I need to check what happens when I plug in a 0 and what happens when I plug in an 8, because those are the endpoints of my closed interval. So let's plug in a 0. P of 0 will give you a negative 1. And let's also plug in and 8. Again, I'm doing this into the original function. So negative 8 squared plus 10 times 8 minus 1 gives me a 15. So I have a critical point at 524, and I have two endpoints. One of the endpoints is 0, -1, and the other endpoint is 8, 15. Now, if I want to find which one is the minimum value on this interval, well, the minimum value has to happen at either a critical point or an endpoint. So the minimum has to be, by definition, this second one. How did I know it's the second one? Well, because out of these three options, it has the smallest output value. So 0, -1 has to be the minimum, because we know minimum is going to happen at critical values and endpoints. I've listed them all. Therefore, the one with the smallest output is going to be the minimum. Similarly, the one with the largest output has to be the maximum. So 524 must be the maximum, because I know maximum values have to happen at either the critical points or the endpoints. Since I've listed out all my critical points and endpoints, I just have to pick out which is the maximum output value. And in this case, that is 5,24. We've found maximum and minimum values of the function on the interval from 0 to 8. I do want to emphasize that the choice of interval makes a big difference. Let's take that same function, and instead of trying to find the maximum and minimum values of the function on the interval from 0 to 8, let's figure out the maximum and minimum values of the function on the interval from 0 to 3. A lot of the same stuff can be utilized that we used earlier. So we're going to do that. We have the same function, but now we're changing the interval from 0 to 3. So we're looking at x values in the range from 0 to 3. I would solve I would find my critical values using the same technique. You can see I get a critical value of 5. Notice that 5 does not fall in this interval. So while it's a critical value of the function, this value of 5 is not in the interval that I'm looking at. So I can kind of just strike it, ignore it, because I know that's outside of my interval. So I don't have the critical point 524 to use in this problem. Now, what's that leave me with? Well, that leaves me with the endpoints. If I plug in a 0, we already got a -1. If I plug in a 3, -3 squared plus 10 times 3 minus 1 gives an output of 20. So my two inputs are 0, -1. My two endpoints here, 0, -1, and 320. Since I only have two options to pick from, the one with the smallest output value is going to be my minimum. The one with the largest output value is going to be my maximum. So if you ever come up with critical values that are outside your given interval, you basically just strike those and ignore those. Because remember, we're looking for the maximum and minimum inside this interval between 0 and 3. If we get anything less than 0 or more than 3, I just strike it, throw it out, ignore it, however you like to hear it, or however you like to handle that. I would like you to find the maximum and minimum values of the function on the interval between -4 and 0. Go ahead, push pause on the video and do that, and I'll show you how that's done on the next video.